All right, thanks, David. So storage is always the hot commodity in data centers and environments in general. Everybody's always needing storage, they need extra capacity, and it's always one of the most expensive expenditures. So lately there's been a lot of people putting in a lot of effort to try to make this cheaper while still accommodating the high performance needs that we have. So today what we're talking about is DataCore and X-IO and how they specifically facilitate that. So who am I and why can I talk about this? Well, I've been with Mirazon since 2007. I've been focusing on storage for about 8 years. Worked with all the major vendors, the EMCs, the NetApp, the Hitachi, the Compellent, the EVAs, X-IO, all kinds of different storage. Pretty much whatever customers have, I've worked on. I've been a DCIE with DataCore since 2008 and a DCME, which is their master certification, since 2013. I've designed storage solutions for organizations of all different sizes. I've had everybody from 500 gigs all the way up to hundreds of terabytes into the petabyte ranges. So I'm very familiar with how all these different organizations play out in different sizes and how things need to be able to scale and accommodate. With that, I also have the actual application knowledge. So the generic Microsoft certifications of MCSE and the VCAP. So it helps a lot to understand how that plays in with everything so that you know where everything ties together and how you actually need to accommodate that. As it seems several of you have noticed, we are putting some polls up through this just to kind of figure out what sizes you guys are and some other things later on. It kind of helps the presentation be a little bit more focused. So it looks like most everybody is somewhere in the less than 100 terabyte range as a whole. So that's a really good niche for what we're talking about. So I'll play into that as we move forward. All right, and we do have one more poll question, I believe. So what do you currently have installed? We basically listed some of the biggest names that everybody has, and then we also have a wonderful other category, which since there's about 10,000 different types of storage out there on the market right now, the other category is broad, but we're basically trying to cover the main big players that we see mostly. So it's looking like mostly a NetApp EMC shop and then the generic other category for the rest of people. All right. Thanks for your participation. All right, so let's start with what is a SAN. And I'm not giving you the basic generic definition that everybody always has. This is what is a SAN at a high level. So all a SAN is, no matter what vendor it's from, it's hardware. Most everyone runs on some form of x86 servers now. So these might be Dell rebranded, they might be HP rebranded. A lot of people use something like a Supermicro that's rebranded. And then they've got some form of HBAs in them, QLogic or Emulux usually. There's a few people who actually manufacture their own fiber channel ports for their storage arrays, but it's very rare anymore. Pretty much everyone uses this commodity storage because it makes their life easier. On the hardware side, you then also have your actual JBODs. Often these are Xyratex or Supermicro. Those are the most common ones that you see. A lot of these get the fancy branding, so they get a pretty face for them that has the company colors and everything, but underneath it all, it's a box, it has SAS expanders in it from LSI, and it's nothing special. And then finally you have the actual hard drives themselves, which are almost exclusively Hitachi and Seagate. They're standard 10K, 15K drives, or they're flash. It really just depends on what you're getting, but it's all from a commodity manufacturer. No one manufactures their own hard drives. And what's funny is if you get a Hitachi array, you're still not even guaranteed to get Hitachi drives. You often have Seagate drives in those, different divisions of the company. So what actually makes it into a SAN? Because what we've listed so far are just traditional pieces and parts of a server or anything else. What makes it a SAN is the software. So the software provides for different functionality. The software gives you your RAID, so you actually get your redundancy. It can give thin provisioning, the VMware advanced array integration technologies, various different things like that, storage virtualization. The software is where all the secret sauce is. That's what actually gives you your connectivity, your global usage of the product. Most vendors tie these two together, and you buy an array and it comes with the hardware and the software. So in the modern dynamic environment, that can cause some problems, because now if I need extra software, I have to sometimes buy extra hardware with it. And we're going to talk some more about that, but that's kind of how these SANs lay out as a whole. Oh, and if anybody has any questions or anything, feel free to ask, and we'll address those as they're relevant. So common challenges. Storage refreshes are expensive. Storage is one of those things that you hear from most people referred to as a forklift upgrade. You basically take the old, you palletize it, they take it away, and you get a whole new pallet of a massive amount of equipment. In the less than 100 terabyte range where we are, it usually isn't literally a forklift, but you're still looking at a major expenditure. You're getting rid of the old equipment, you're buying all new, you're chucking it in, and it's a big ordeal. You also have to worry about vendor lock-in. Vendor lock-in is one of the most painful things that comes from storage arrays, because the hardware and the software is tied together. When you want to upgrade the software, you have to buy new hardware. When you want to buy new hardware, you have to buy new software. So you have to buy the same things you've already owned just to get an extra feature. This really limits the ability of the organization to adapt as needed and creates a lack of flexibility. And then performance. As we're putting out this poll, which most of you have already started voting in, not enough performance is currently one of the leading factors next to cost. Performance lately has become a massive impact for environments, especially with VDI. VDI is basically the killer when it comes to storage. Normal server workloads, everybody assumes, will be much, much heavier than desktops, but in reality, desktops are much heavier. People opening IE and all the cached files, all the cookies, everything else that gets stored on those desktops as they're running creates a massive storage challenge. Additionally, you have new products that are expecting SSDs. A lot of the new storage arrays, a lot of the new ERP products and different things like that are expecting you have SSDs in your storage array, so they're expecting a certain level of performance. And honestly, they're getting a bit lazy with their code, which is what's making the performance. So that's becoming pretty big. Compensate for bad software with hardware. It's always been the case for years, but now it's really hitting home because SSDs are such a game changer on that performance line that people are getting even more sloppy with their code. Other major challenges: maintenance consumes time and resources. This is one of those things where it's not necessarily that you have to do a lot of maintenance, it's just absolutely terror-inducing a lot of times when you have to, because this is what everything in the entire organization is running on. Everything. If I screw this up, everything goes down. Or depending on what kind of maintenance you're doing, you might have to take down the storage array. And in that case, like for example a forklift upgrade, you've now caused an outage of your entire environment, everything. All your users, servers, everything can't work until this comes back up. So if there's any issues during that upgrade, it becomes a major problem. So as we go through this, I'm going to talk about a few client examples. I wanted to kind of pre-stage these so you guys had an idea of where we were going and some of the examples. And if any of these line up with your environments, it might also be interesting to see how we solved it. So our first client example, they need a shared storage solution that provides the ability to scale without interruptions or downtime. This customer is just getting into shared storage. This was probably 6 years ago. They were getting into VMware. They are a service provider. They really needed that kind of performance and scalability, mostly when it came to things like being able to live migrate servers. They were really interested in it. But they're also an extremely dynamic organization. When we started working with them, they had 3 racks of equipment. I counted yesterday 24. So over 6 years, they've had a massive growth rate. So they wanted to be able to get that expandability, but they wanted to limit the costs associated. They didn't want to have to buy the high-end Ferrari today when all they really needed was a focused performance. They also needed to get in it for relatively cheap. If any of you do any work with service providers, you understand that every single penny you can save is a penny earned, and it makes it cheaper for your customers, which allows you to get more customers. So they really need to get into it cheap, and the DataCore X-IO solution solved their problems for them, and we'll talk about how at the end. Client number 2 had underperforming storage. They had a unplanned VDI deployment. They were out of storage capacity due to increased growth. The cost to upgrade their solution was extremely inhibiting. The quote they got from their vendor ended up being almost $600,000 just to upgrade their controllers without adding any additional storage. The quote from the customer on that involved several expletives, and they were thrown out the door, which is why we don't list it specifically. So we'll get to how we solve those in the end, but here are the products that really help facilitate all this for the customers. The first is X-IO. So X-IO has been around for quite a while. The ICE intelligent storage elements that are for sale now were developed specifically by Seagate to address storage problems. A lot of this came with physical degradation from environmental factors such as vibration, heat, other things like that. Performance concerns, storage is slow, storage is slow. Storage during a rebuild is really slow. And capacity efficiency. I bought 80 drives from this vendor, but they're telling me that I can only have arrays of this size, and for every 10 drives I have to have a hot spare, and in the end I'm only getting a quarter of my capacity. But then, because on top of that, they tell me once I get past a certain amount of usable capacity, I need to buy more for performance at that point. So some of the general numbers that have been pulled from these vendors' actual technical documentation for when you need to add additional capacity are listed in this small graph here. Compellent and NetApp are some of the worst offenders of this, and a lot of it comes back to the way they do snapshotting. They almost require snapshotting when they're setting these up. They want them to run all the time. Also, with the way they write to all the disks, they often run into, Waffle especially, performance concerns once those disks start getting more than about 60% full normally. So you really don't get the capacity you buy. You might buy 20 terabytes but only be able to use 8 or 10 of it. And that was another issue that was plaguing this customer, was they did not have enough capacity to solve their needs, even though they had almost double in physical spindles what they needed. X-IO is different from most storage providers. They don't try to force storage hardware to perform a lot of software tasks. They've kind of decoupled that hardware and software pairing that we talked about earlier. They designed these to operate for 5 to 6 years, and they have 2 to 10 times the performance of alternatives with similar hardware, and often at 30 to 70% of the total cost of ownership of those competitors. So we'll get into that a little bit more, but who is the company? Well, like I said, they were developed, this technology specifically was created by Seagate in the early 2000s. They were getting a massive amount of hard drive returns. These returns were coming back daily from people, and they would go put them on the bench, and there would be no issues with them. They would be perfectly fine. So why were they getting them back? What was happening? Well, something between that RAID controller and those disks got unhappy. It could be that the disks momentarily got slightly sluggish in its response due to a single bad block or something. And rather than try to fix the problem, the RAID controller just threw the whole disk out and started a rebuild. So it wasn't that the disk itself was necessarily bad. It might be one block out of the millions on the disk, but the whole thing was thrown away. Then you have to do a rebuild. Those rebuilds can take a while. And then when the disk gets back to Seagate, they put it on the bench, slap a refurbished sticker on it, and send it back out. It's wasting a lot of time. So they created the ICE to re-engineer from the ground up with a new approach. So rather than have the individual hard drive being the failure point, they put multiple hard drives together in an enclosure that treated them as one logical drive. So rather than having to fail a drive, repair a drive, etc., they're able to do small granular repairs on this storage. Then they built in a grid array. So rather than having these monolithic controllers like you're used to seeing with most of your EMCs, your NetApps, your IBMs, the big guys that everybody's familiar with, I'll call them monolithic arrays so I don't have to keep listing off names. They wanted something that made it easy for people to expand as needed without having to upgrade their controllers. So they developed these in small units that make it easy to grow. And that is the X-IO ICE. They realized an individual hard drive is inefficient failure. That one block just caused me to lose an entire 4 terabyte drive. That doesn't make sense. So rather than treating these as entire drives, they treat them as multiple surfaces of those platters within that drive. So modern drives have anywhere from 1 to 4 platters in them. So rather than thinking of that whole drive as an entity, if a hard drive has 4 platters of storage in it, it looks at that as 8 surfaces, each side of the platters. So rather than having to do operations at the global hard drive level, even down to rebuilds, it doesn't have to rebuild the whole drive. It can rebuild just one surface of it. It can go in and decommission just small parts of that drive. So if a few sectors aren't playing well, it can decommission those, keep the performance of the whole drive, prevent a full remirror, and prevent the end user from having to go in, swap the drive, watch it, make sure it rebuilds, make sure everything comes out happy, and deal with the performance impact of that. They then allow for in situ repair of issues through a very special combination of firmware from Seagate. So they essentially have the Seagate bench firmware built into these units. So if you ship a drive back to Seagate, they put it on the bench, plug it in, and run a set of tests on the drive to validate if there's issues with it. That's built into the ICE. If they try to do minor repairs to the drive and it's not properly coming back, it can actually load the Seagate diagnostic firmware directly on that drive, recalibrate head height, recalibrate spin speed, everything like that to make that drive better and put it back into production rather than having to throw it away. Again, it's all about making everyone's lives easier. Each ICE independently presents a fully redundant solution. So you get an ICE chassis and it has 2 controllers in it, 2 power supplies, redundant cache backup, as well as the drives that are all rated. So if I need to buy 20 terabytes of storage today, and I'm running some servers on it, but it's not extremely high performance, I can buy that today. If in a year from now, we suddenly have a VDI initiative kicking off, and we need some really high performance storage, well, now I can buy another small piece. I can buy something that's not that large, but has a lot of performance to it. So a lot of flash in that, for example, with some auto tiering to get just what needs to get to that flash up there, so that I don't have to worry about having it on the same controllers. Oh, well, this was fine for a year, but now we need VDI, now we need new controllers, now we have to basically pick everything up and throw it away. That's not efficient, and it's very painful for the organization. So these smaller building blocks allow you to buy what you need when you need it. There's also 3 different tiers of storage, depending on with different capacities and different performance of each one. Very similar to what you're used to seeing in most storage arrays. You can connect that 2, 4, or 8 gig fiber channel, as well as 10 or 40 gig iSCSI. So pretty much everything you need for modern connectivity, these units accommodate. And they're all managed and monitored through a single pane of glass ICE manager. You know, it's great if you get these small building blocks and you get that granularity, but if you don't have a single pane of glass to manage it, it's very difficult because now you have to chase down which array something was on. ICE Manager provides the solution to that. It gets you an all-in-one single pane of glass where you get to manage everything. So now we've got small units of storage, smaller units of storage that are highly available, highly redundant, and we can get just what we need when we need it. So it allows for a much more granular and reactive IT organization rather than having to be proactive and go, all right, what might we possibly need in the next 6-year life cycle of this storage array? All right, we need to buy something that can accommodate for all of that. There's 3 different types of storage. The 200 series, as it's called, these have anywhere from 20 to 40 hard drives in them, ranging from 3.4 terabytes up to 27.8 terabytes, usable, formatted RAID 5 capacity. And when I say usable, you can have it 99.99% of the way full, and there is no performance degradation. So all the way from the first day you put it in until it's 100% full, it performs exactly the same. And this really comes down to the way in which they've specially developed these storage arrays. Since they've developed it with multiple drives together treated as one unit, they don't have the same performance tailing that many different storage arrays do. Each of these arrays will give you somewhere around 10,000 to 13,000 IOPS. It really depends on your workload. This is a write-heavy, extremely random workload. I'm probably not supposed to say it. It is the SPC benchmarking from the Storage Performance Council. They don't like that to be used as any kind of benchmarking number, but that's what it is. So these are a real industry standard number. This is what you actually get out of it. However, if your workloads are sequential in nature, if they're easy to cache, I've seen one of these units with just hard drives and just 40 of them push 20 to 25,000 IOPS. But you can pretty much take to the bank every time 10 to 13,000 IOPS. The 700 series, this is their hybrid array. So this has 10 SSDs and 30 hard drives. These size range from 5 to 20 terabytes, usable, formatted. Again, everything is usable, formatted, 100%, 0 to 100% same performance, day 1 to 5 years from now. On these, you get anywhere from 60 to 120,000 IOPS. It really just depends on, again, your workload. If you have a workload that has a lot of read-heavy activity and it's very predictable, you can easily exceed numbers like this because it all ends up on SSD. You're reading purely out of SSD, purely out of cache, and performance is extreme. One of the nice things about X-IO is you get full lifecycle confidence. The technology built into these arrays is so, X-IO has so much confidence in it. They give a 5-year hardware warranty out of the box, no extra expense. Anyone who's worked with the major monolithic arrays has probably experienced at some point where you buy it with 3 years of support. Great. That was only like $5,000 a year. That wasn't that much. All right, it's year 4. I need a new quote. And you get a quote and it's $15,000 to renew your support. It's like, whoa, what? How did my support go from $5,000 to $15,000? How did it triple overnight? Nothing changed. It's the same array. It's only 3 years old. Why did it go up so much? That's caused a lot of problems. X-IO comes with a 5-year hardware warranty right out of the box. It performs the same all the way through its life cycle, so you don't have to worry about those forced upgrades simply to gain additional capacity. No forklift upgrades. if I bought an ice today and then I buy another one in a year and then another one in 2 years, if my 5 years is up and I'm done with them, if I don't want to extend warranty, I want to get rid of them, I can just replace them as I bought them. So I can replace the one I bought the first year, but leave the ones from year 2 and 3. I don't have to completely throw everything away and start over, which makes a much nicer budgeting standpoint, because you don't have to basically take your entire IT budget for a year and say, all right, well, this year's whole budget goes to the SAN. Maybe next year we can add those 2 switches we wanted. It allows a much more predictable growth rate, and all of your replacements don't come at one point. The X-IO storage also phones home. So proactively, it will talk back to X-IO corporate. As it talks back, it will tell them how it's running, what kind of issues it's having, if any, so they know before you do often if there's anything going on that looks a little awry with the array. I've had simple examples from customers. They unplugged the power cord from the redundant power cables to move it, and they got a call from X-IO that said, hey, we just saw a power supply go down on your arrays. Is everything okay? I'm like, yeah, sorry, we were just rewiring some stuff. But that proactive maintenance is a very useful thing for IT organizations, especially since most of you listed you're less than 100 terabytes. You're probably not just overflowing with IT resources. So to be able to take something else off their plate and give it to somebody else provides a much better product overall for you. So that's kind of X-IO's story. So what we didn't talk about was software features. Well, they don't have a lot of software features. They've spent their development on making storage what it should be. Very fast, very, very, very reliable, and easy to manage. So you don't have, so they've not built a lot of those extra software features into the array. It's very, very fast, very reliable storage. So what if I actually need some of those extra software features? You know, you might be able to get a lot of them through your hypervisor. What if I need those extra things? Well, that's where we can pair it up with another product called DataCore and get a really good overall best storage, best software product. Sorry for that. What is DataCore? Well, DataCore software. It is only the software portion of the SAN. It is software-defined storage. For whatever reason, about 2 years ago, the industry suddenly jumped on this concept of software-defined storage. Never had heard of it before, but now it's a big buzzword. Well, DataCore has been doing this since 1998 is when the company was formed. They've been around a long time. It's not a new thing. It's a well-proven product. There is no hardware sold by DataCore. It is only the storage software. That forces them to make their software really, really good. Just like X-IO only sells hardware, so their hardware has to be really, really good, DataCore only sells software, so the software has to be really good. So how do you decouple it from hardware? Well, the way they do that is it runs on any x86 commodity hardware. You pick your vendor, you pick your Windows operating system, 2012 R2 latest. When the next version comes out, you'll be able to put that on. And you install DataCore. It turns that into a storage controller. The minimum requirements are negligible, but it scales extremely high. You can have anywhere from 2 processors up to however many you can get. The new Intel processors, you can get dual 18-core procs in a box. Connectivity. 1 gig, 10 gig, 40 gig, 56 gig iSCSI. Pretty much anything you want on the iSCSI standpoint. 2, 4, 8, and 16 gigabit fiber channel. So as anyone in the call who hasn't heard of DataCore before is probably currently thinking, yeah, but Windows? Really? Do we want our SAN running on Windows? Well, the reason is pretty straightforward. Greater compatibility. When new products come out, they're pretty much qualified on DataCore immediately. They're for DataCore immediately because they're qualified on Windows. Windows has the largest install base. People qualify their products for Windows immediately. And pretty much if it's qualified to work with Windows, it works with DataCore. So when SSDs were first starting to get big, DataCore had the widest support for them. When 16 gig fiber channel came out, DataCore was basically the first to market be able to support that, because their software just has to support what Windows supports. The other thing that goes all the way back to the late 90s when they were first making this product is it prevents kernel support issues. If you make your own custom Linux kernel to run on your storage array, you now have to support that kernel, top to bottom. Everything about it you support. So it may have started out as Red Hat Linux, but now you have to support it because you've made changes to the kernel and make it support the storage array. That causes a massive headache from support, and it means you have more of a lag on how long it takes you to go to market with new features, because you have to qualify the entire OS. So DataCore gets around a lot of those. In DataCore, the actual I/O drivers run I/O performance comes straight out of drivers. So it's as close to the kernel as it can get without actually having to modify the kernel. So as expected with a software-defined SAN, if they only make software, they better have a lot of features with it. And they do. On the screen right now, I have listed a high level of most of the features. There's more that honestly we're just going to take too long to talk about in this webinar. And for the next few slides, we're going to dig into how these features work. So virtual SAN. VMware has been hot and bothered about this for the last couple years. They want you to run virtual appliances in their storage that take whatever you give it and then present out an array from it, essentially. We've been doing this on DataCore for about 6 years. Install DataCore virtually, give it storage, and serve it out. So this isn't anything new. It scales out to up to 32 nodes. So you can have a large grid of storage nodes, higher than most everybody in the industry. You get the features of DataCore without dedicated hardware. So maybe I don't need much shared storage. Maybe I only need 500 gigs, a terabyte for one specific thing. I can spin up a couple DataCore nodes, not have to spend a lot of money, and get it up. But it also scales massively. One of the things you're seeing if you've been looking at a lot of the industry, so VMware has started launching a lot of these traditional virtual SAN models where you take commodity, air quotes, storage, put it in your server, put RAID on it, put some SSDs in, and now you've got a virtual SAN. But if you actually look at the numbers for most of that, the way they're requiring you to set the storage up in the hosts actually makes it as expensive or more than actually buying a real storage array. So we've not seen as much of that as one might expect in the software-defined era. Most people are still putting a real quality class storage behind it, even if they're running that front-end storage controller virtually. Another feature of DataCore is storage pooling. This allows you to combine multiple RAID sets and arrays together to get the capacity and performance of all of them together in one pool, rather than having to carve out, and this RAID 5 is for these people, these 4 are for this. You can combine that in a large pool, which gets you really good capacity optimization and performance. For example, maybe I have a grid storage system like X-IO, and I've got 10 different ICE. I can pool those together in DataCore and write my storage across all of them at once and get my high quality performance of all of them combined together. Caching. This is a great feature of DataCore. Everybody caches now. If you look through the industry, you can cache at the VM level, you can cache at the host level, you can cache in-line at the HBA level with some of the QLogic technology. There are caching appliances you put in-line on the fiber cable that do nothing but cache. Cache is huge. And DataCore does cache pretty much better than anyone. It takes whatever RAM you put in that Windows box and it uses that for cache. So you can go up to a terabyte of RAM cache. RAM's the fastest thing you can get. It doesn't matter how fast your SSDs are, RAM's faster, can guarantee it. So what a lot of customers do is they take their storage and they supplement it additionally with extra RAM, because it's never like a user says this is running too fast. Even when they have fast storage, they like to put something to give that extra little bit. So Even with X-IO, this helps because it eliminates a lot of the reads. DataCore will read cache, read ahead, all that normal stuff with almost all of this RAM. It uses some for write coalescence to make the writes faster, but in short, it's a big read cache. VDI deployments, it's excellent. It can definitely hold your entire golden image almost in RAM. Then, of course, you have all the writes. The writes have to make it to disk. That's where you still need a high-performance storage behind it that can actually accommodate all of those writes. Auto-tiering. This has been around for several years with some vendors. Compellent had this data progression for probably 6 or 7 years ago. But it always had a few quirks to it, and you always had very specific requirements on how you could use it and what you could do. DataCore, again, it's open software. As blocks get hit heavily, they're promoted up to faster storage. You can have up to 15 storage tiers in DataCore. I can't name 15 different speeds of storage off the top of my head. DataCore allows it. Future growth. Who knows what tomorrow is going to bring? Let's go ahead and allow them to have those extra tiers. Dynamic constant migration as a background task. One of the problems with a lot of storage arrays as well is they only escalate hot pages up once a day or maybe twice a day. So it combines all the I/O metrics for the whole day and then makes one decision on what it moves. But it doesn't do it granularly. X-IO and DataCore both do it very granularly. So every 5 minutes you're looking at things moving around as necessary. X-IO actually does an ROI calculation on this as well. So it figures out if it's worth its move. And the two products complement each other very well. DataCore at a high level looks at moving things up, then X-IO puts it exactly where it needs to be on the disk underneath to give you that real performance you're looking for. Random Write Accelerator. This is a new feature with DataCore. Essentially, as you get writes into your environment, if they're really, really, really random, SSDs don't like that. SSDs aren't good for writes. SSDs suffer when you try to write to them. The Random Write Accelerator, you essentially sacrifice capacity for performance. Rather than overwrite old data, it writes things net new and then cleans up the old data. So random write performance, they've seen peaks up to 300 times faster, depending on the workload and how slow the back-end disk was and how well it could accommodate that. Data migration. One of the nice things too is DataCore makes it very easy to do upgrades. So we've put DataCore in front of older storage. The customer needed to fix some software issues. We put DataCore in, it fixed the software issues. Then they're ready to actually upgrade their hardware though. Well, since DataCore is software in front of but apart from the hardware, it allows a very easy way to migrate that. Essentially, you right-click on a disk and say, move to this new storage. And it migrates it from disparate arrays from different vendors, from different speeds, everything as needed. You can also manually balance your performance in that case. So if you have different tiers and you don't want to use auto-tiering, you can manually split it up. Synchronous mirroring. This is one of the features that very few people in the industry have right now. This gives you 2 entire copies of your data in lockstep and allows you seamless failover from one set to the other. That's the key point that most vendors don't support right now, is that seamless failover from one set to the other. What a lot of my customers do is they'll take their 2 data cores and split them geographically, be that over different rooms in the same building, be that over different buildings on a campus, be that between 2 separate campuses. And then they stretch their VMware cluster. And now if they lose either data center, either building, they can fail over. So it allows for a very high level of availability. And then there's the traditional asynchronous remote replication. This allows you to get your data to another site, mostly for DR, over slow or latent links. And we also have continuous data protection. This logs every write that comes into the SAN and allows you to fail a volume back down to the second. So if I had a big virus outbreak at 8:50 this morning, I can fail back to 8:49 and 47 seconds if I want to and recover my data from that point. Obviously, it uses a lot of storage for that, but you can make multiple rollbacks, and if you need that kind of availability, it's got it. Centralized management, up to 64 nodes in a single pane of glass. All functions for all nodes. Historical performance recording as long as you want it. You can record to a SQL database and keep it as long as you want. You can pick which individual items you want to record and set those up, and it will record them indefinitely. There's hundreds of different counters that it can record. So pick what you want, tell it to record, and it keeps all that for you. And then reports of configuration. One of the most challenging things in IT as a whole is what changed? Something broke. What changed? You can create reports in DataCore that show you exactly what your config looks like today, and then when you have issues, you can compare the two. A new feature is quality of service controls. This allows you to limit the performance of certain virtual disks. So noisy neighbors. Maybe my QA team is testing a new version of the software. Maybe that's not a good version of the software. It starts destroying the storage of some cycle of loops that it's got built into it. You can limit that with DataCore to where it can never exceed a certain amount of storage usage. That means that it doesn't DOS your main production environment. You can also use this for chargeback. It will keep track of how much performance and capacity each of those disks used throughout this period of time. So then you can say, all right, accounting, you guys need to start spending some money on the storage because you're using 90% of our performance. You need to start giving us something. And then the last feature I have actually listed here is online snapshots, differential or full. Pretty much everybody can do this now, but you can create and delete as many as you need. They work pretty much like everyone else's. So now we've gone through these products. Let's talk about the actual implementation of this, what it looks like. So we talked about how we had some customers who were having different issues earlier. And there's another poll going right now for what type of workloads you're running, because it probably lines up with what one of these customers was running as well. The first customer, they really needed a dynamic growth capacity environment. They started with DataCore in 2008. They didn't need much storage at all, just a terabyte or so. They put 24 internal drives, 300 gig, in a super micro box. But they kept having failures. They were replacing drives all the time. Then a RAID controller would fail, and they'd try to go get a replacement, and it's the proverbial needle in a haystack. They're digging around everywhere trying to get this RAID controller, and they can't find it, so they have to get a new RAID controller. Then they have to see if that RAID controller will actually work with their old RAID set. So it created a lot of issues from maintenance side. And then performance wasn't keeping up. Like I mentioned, this customer grew from 3 racks when we started with them to something around 24 now. Very high growth, and those boxes just couldn't scale that high. They started at 1 gig iSCSI too. Nothing special. Over the time, they have grown organically to, well, they've added fiber channel to each server. They direct connected 1 ICE to each server. So they immediately got a big performance boost on that side. They added a switch so they could add multiple ICE behind each data core. Then they were like, all right, now 1 gig front end is really our bottleneck because this storage is just flying. So then they added fiber channel cards to their front end, but only their new servers. Their old servers they left on 1 gig iSCSI. So their old ones they didn't have to put new cards in, their new ones are fiber channel, presenting the same disk to both types out both at the same time. So 6 years later, without any storage outage from any upgrades, their entire environment's been upgraded. We've replaced the controllers, we've replaced the back-end storage multiple times, We've expanded the back-end storage. We've expanded the front-end connectivity. We moved them from one data center to another with absolutely zero storage outages from any of this maintenance. And here's what they look like today from what you saw earlier. And I actually just installed 4 more ICE for them yesterday. So they've actually scaled quite a bit larger than this even. But they run all of their primary production storage off X-IO. I've seen anywhere up to 80,000 I/O coming off their back-end storage, and this is only spinning disks with absolutely no flash back there. They then have some other storage for their test and QA. So this, they weren't really worried about the performance, they weren't really worried about the reliability, so they've got some Dell and some Nexan, some other stuff over there for that. And they present it all up through the same unified platform. So it's allowed them a level of flexibility and growth, and then the X-IO storage has kept up with and accommodated all of their needs. And it seems like from our poll, most of you experienced a very similar thing. You had issues with server virtualization, 95%. That's why you're looking at shared storage. That's what they were going for, and they accommodated it. Our next customer, I mentioned, had an unexpected VDI deployment. Their NetApp was underperforming. At peak times, the average latency was over 30 milliseconds. The average, not the spikes, not the really high hits, the average. VMware says your average should never exceed 20 for any length of time. When they went to look for additional performance, they had to upgrade their controllers. Well, the 5-year cost to upgrade their controllers and get support on it was looking at $600,000, which they thought was obscene. They also needed a better DR situation because right now they had backup sitting somewhere. So they had to get storage, they had to get array servers, and they had to restore everything. They replaced the NetApp with DataCore and X-IO. They put a DataCore in each of their their co-location facility and their main office, 20 miles apart, with dark fiber. The X-IO immediately eliminated their performance concerns. Their VDI suddenly went from taking up to 3 minutes to log into a desktop to being around 30 seconds to get into that same desktop. Things immediately got much better. Users noticed. Their applications started functioning much better. Everything was running a lot better. Then they stretched it 20 miles at that point. It was actually after the fact. So now they can lose their main office, and VMware HA will bring up their VMs in the other location automatically within just a couple minutes, way before they've even got time to get in the environment, figure out what's happened, and start recovering from it. Their VMs are already coming back in the other location. The average latencies we're seeing now are 0 to 1 milliseconds. We're getting spikes to 5 to 7 milliseconds during heavy I/O times, like 9 a.m. when users are logging in, and the end of the day when users are logging out of their VDIs. So their performance concerns have also gone away. The entire replacement solution, 2 sets of storage, 5 years, total cost of ownership for the DataCore software, controllers, the X-IO storage, as well as the networking to connect everything, $480,000. So less than the cost just to upgrade the controllers and get support for their NetApp solution. So it's not just that this is a great solution, but then it costs what a great solution often does. It's a great solution and it's affordable. So you can actually get the benefits of the storage where it needs to be and not have to pay for everything multiple times. So X-IO DataCore. It's really the best combination of hardware and software. DataCore is dedicated to making the best software possible. That's all they make is software. They have to make it well. X-IO is dedicated to making the best hardware possible. They focus on hardware. They don't focus on software features. So their hardware is just rock solid. Every time I go ask a customer for a testimonial for X-IO, it's almost unilaterally, well, I honestly don't have much to say. We set it up and it's just worked for the last 3 years. We've not really touched it. We do a firmware upgrade when it comes up, but we've not really done anything with it. It just works. which I think is one of the best testimonials ever, actually. It's short, but if you have absolutely nothing to say except for it does exactly what it's supposed to do, then that's pretty awesome. You get the most reliable storage and the most innovative feature-rich software. So a lot of questions come up around why would we put DataCore in front of this? Why would we look at doing multiple copies of our X-IO with X-IO already being as redundant as it is? Well, the reason comes down to environmentals usually. What happens if a tornado comes through and takes out your data center? Well, now we need somewhere to spin stuff up. The physical storage is just gone. Doesn't matter how reliable you make your storage array, if it gets hit by a tornado, it's going down. The other thing is simple things like water leaks. I've had many storage arrays over the years that have had water leak on them, from re-roofing the building to, oh, there was an air conditioner in the ceiling and the condenser pump went out. Again, no matter how reliable you make your storage array, if it gets soaking wet, it's going to go down. One of the reasons these two pair so well together additionally is there's no feature overlap. You only buy the features you need once. So software features you buy through DataCore, hardware features through X-IO. You don't end up putting a really intelligent array behind DataCore and then not using any of those arrays' features. And then DataCore allows for an easy and simple migration to X-IO, and it allows you to easily grow and expand it. So what a lot of customers have done is put DataCore in front of their old storage array, and it helps it gives it extra life, and then when they're ready to upgrade, they put X-IO behind it and easily migrate over to it. So that's my presentation. At this point, we've got a few minutes left. Anybody have any questions? Looks like there's one. Let's see. Yeah. So, yeah, essentially it was regarding how DataCore functions with or without X-IO. We have customers who work with X-IO and DataCore together. You know, they really need that high-level performance. They want the extra features. They want simultaneous iSCSI fiber channel, multiple different forms of connectivity, everything like that. And then we also have customers who just want storage on its own. So each product fully functions on its own as long as you know what you're looking for. All right, so another question. With SAN features moving in the stack, how does that affect traditional SAN solutions in the future? So it's a really good point. VMware keeps pulling more and more features into the hypervisor. So does Microsoft. Microsoft's pulling more and more features into the hypervisor. Do we really need intelligent storage? Can we just put commodity storage behind it? Well, honestly, sometimes the answer is yes. A lot of times the answer is still no, though. One of the things that comes in with that is most of those products are still fairly early in their infancy from the actual storage management standpoint. So while they can make the storage work and they've added a lot of the functionality in the hypervisor, it doesn't necessarily do it as well as a storage array would. For example, VMware's thin provisioning. It works pretty well, but it's not as efficient and as fast as DataCore's thin provisioning, because VMware's thin provisioning zeroes the disk and then writes the data as it happens. DataCore pre-zeros, as an example. So having that functionality in the SAN can add a lot more benefit at that standpoint. What's the process of moving existing storage behind DataCore? Is there an outage? We do this a lot. I've done large projects for household names who I don't have the ability to say, actually. Sorry about that. But they needed to move from their old array to their new. This customer was moving actually from an older X-IO array to a newer X-IO array. Multinational contractor, billion-dollar company. So they needed to be able to get over to that. We took a 15-minute outage and we put DataCore in line. We passed those disks directly through DataCore up to their storage array, or up to their hosts. Excuse me. At that point, the hosts have their storage again. The hosts start working. Once DataCore is in front of it, we then mirrored over to their new X-IO array on the fly with absolutely zero interruption. Then they removed their old storage array and then actually added another storage array behind it. So they were able to completely get rid of their old storage with a single 15-minute outage. And all that outage was rezoning and representing the storage from direct to host through DataCore. Does this integrate with VMware? Yes. Both products integrate with VMware. DataCore and X-IO both support VAAI primitives, either together or separate. So yes, in short. They also integrate with the Microsoft solution, so the whole System Center stack. Let's see. Yeah, I think that's all the questions right now. And we actually made it on time. That's impressive. So without anything else, I'd like to thank everybody for attending.
Yeah, thanks everyone. This is David Phillips again. We'd really like feedback as far as, how you liked the formats, maybe what future topics you'd like to see. And if you could kindly enter any responses into the question section, we'd certainly love to hear from you. But thank everyone for attending. Thank you very much. And thank you, Brent, for presenting. If there's nothing else, we'll leave it open for a bit to try to get your feedback, and everyone have a great afternoon.